Hello everyone. In this video I want to show you how to basically run an output with two inputs, one a start and one a stop button. Imagine you are going to run a motor. You have got a start button and also a stop button. We need to know our push buttons. They are momentary push buttons, so when you press the push button, for example, when you press the start button, the input value goes high, and when you release the start button, it goes back to low. Let's simulate a motor with two inputs. We either can put the address here and give them a tag name for each input and output, or the better way is go to the PLC tags and then into the default tag table and create basically a tag table. So I have already created my tag table. So I've got 4 inputs and 4 outputs, which I'm going to use for this basically lesson. I am going to create another input and I'm going to use it as a stop button. So a stop and it's going to be an input address. Obviously I have used I0.1 to 4, so I'm going to use I0.0 as my stop button. You can pick any other addresses, doesn't matter. Right, so now we can go back to the main OB1 and let's say I am going to use input number 1 as my start button, and then the stop button is a normally closed switch in this case, and also I have got my output number 1 as my output. Right, so now if we to be able to download the program we have to be offline. So now you can click on the PLC, download the program into the PLC, and then load. Finish. No errors, so now we can monitor the program and see how it is working. So now if I press the start button, so you can see the output turns on, and if you press the stop button, the output will go low. So the normally closed switch will open and it will stop the output. But the thing is, if I show you the PLC on the video, so this is my input I0.1 and that's my stop button I0.0. So when I press the start button, you can see the input goes high, so of course it's been pressed, and the output, which is the motor or the output number 1, is on as well. And now if I press the stop button is high, is activated, the output goes low, as you see. But we should know in industry, normally most of the push buttons, they are momentary push buttons. So for example, when you press the start button, the output turns on, and when you release the start button, you don't want the output to turn off. You want it to keep running until you press the stop button. So in this case, if you are using a momentary push button, we need to solve this problem in the program. How we can do that? It's very simple. There are 2 different ways that we can latch the output. So one way is At the moment, the problem is with the start button. It's a momentary push button. We want to latch it. When you press it momentarily, you want to output turn on and it stays high. So we make a parallel line, put it normally open, and make it parallel with the start button. So in that case, the parallel line with the start button is going to be the same address as my output, Q0.1. So I use the same address here. So now if I download the program, and if I monitor it, we will see how it is working now. So now if I press the start button, the current will flow through this direction. The stop button is not pressed, so it will let the current to pass and turn the output high. So now if I press the start button, the current will flow through the start button. The stop button is not pressed yet, so it will turn the output high. Now if I release the start button, see what happens. Now the start button is released now, so the output stays high. How? Through this parallel line. So now the current is flowing through this direction. And it will stay high, the output, until I press the stop button. Okay? So that's a traditional way of making a motor working with a start and a stop button. However, there is an easier way, is by applying SR flip-flop. I'm going to show you a different way in ladder logic. So if you go to the bit logic operation, you have got your SR flip-flop. Okay, so simply you can drag and drop your SR flip-flop here. Also, it needs an output. Of course, it needs a start button and a stop button. Okay, right. The SR flip-flop is a memory bit address, so it can memorize everything. I am going to use I0.1 as my input, and then I0.0, which is my stop button, and then for the output I am going to use a different output address, Q0.2, output number 2. However, as the SR flip-flop is a memory bit address, so I need to address it with a memory bit. I use M0.0, so M stands for memory bit. Byte number 0, bit number 0 is being used for this SR flip-flop. So now, if you download the program, this network works exactly same as network number 1. So now we want to see how it is working. I am going to monitor this program. Okay, program is monitored now. So now if I press the start button even momentarily, it will turn the output high, and now the start button is released now. It's low, however the output stays high, because this SR flip-flop with the memory bit can remember that the set bit is already been activated. So it will stay high until you reset the SR flip-flop. And also we call this SR flip-flop set and reset flip-flop. So now if I press the stop button, it will reset the output. What you need to know, in this case, we use a normally open switch for the reset. So if you compare the two networks together, in the first network, the stop button was a normally closed switch. In the second network, we are using a normally open switch. Because if it was a normally closed switch, I am going to show you, it will always constantly resetting my SR flip-flop. So you never be able to set the SR flip-flop. So that's why we use a normally open switch. Now we are going to learn how to create the same program or SR flip-flop in SCL language. So I need to turn the monitor off and create a new network in SCL. So now we can start. So one thing I forgot to show you, in SR flip-flop, normally reset has got priority to set button, which I'm going to show you here. For example, if I press the start button and a stop button at the same time, for safety reason, SR flip-flop won't turn the outputs on. So you will see now both input and reset and reset inputs are active. Well, you can see the SR flip-flop is not turning on. Why? It's because the reset has got priority to set in these kind of flip-flops. So now if we are going to write the same program in SCL language, we need to create an if function. So we say if, open the bracket, input, I'm going to use input number 1. Let's say this is the start button. If input number 1 is equal to high and the stop is equal to low, then semicolon. So here we are making a priority. We say if a start button, input number 1 is the start button. If a start button is high and a stop button is low, what it means, the start button is being pressed, however the stop button is not pressed yet. In that case, the output should turn on. So let's say output number 3 should be equal to, so we are writing the output. That means returning the output from low to high. So we use colon equal to 1. We close the line with semicolon. However, now we didn't define what should happen when a stop button is high. So in that case, we create an else function. We say else if a stop button is high, then output number 3 should go low. Should change to 0. Semicolon. And now we need to have a look to the program, because we have got 2 if function as you see here. So we need 2 end if to close both if functions. So end if and also, so now I close this if function, as you see the line here. Now I need to close the first if function. So end if again. There you go. Right. So now if we download this program into the PLC, we want to override the main OB1 as we made some changes. So now if we zoom in a little bit and then monitor the output, actually monitor the program. So let's have a look here. We have got input number 1, which is my start button. We have got a stop button, and both of them are not active at the moment. So obviously the result is false because the start button is not pressed yet. So now if I press the start button, you can see the output turns on. However, the start button is 1, the stop button is false, it's not been pressed yet. If I press the stop button, now I release the start button, so you can see the output stays high until I press the stop button. If I press the stop button now, the output will go low, as you see here. Okay. Thanks for watching this video. In the next video, I will explain how we can apply timers and counters in ladder logic and SCL language.